For many years, Pluto was regarded as a unique object in our solar system. However, recent talks led by renowned astrophysicists Neil deGrasse Tyson and Michio Kaku have rekindled the debate about Pluto's status, prompting additional research into its role in the cosmos. These scientists have proposed that Pluto might be headed for a collision with Neptune, raising a number of concerns. Is this a rare and unique cosmic event? Or is there a more complex and profound explanation for this theory? Let us examine what a potential collision may look like. How could such a big event unfold? What would the impact entail for both planets and the solar system at large? According to important research by top specialists, the Neptune collision may indicate that Pluto, which was long thought to be a smaller and more distant planet in the solar system, continues to pique scientists' interest. The main question now is whether such an event poses a real threat to Earth and how this could have happened in the first place. Tyson and Kaku are among the astrophysicists who have expressed concern about the possibility of a catastrophic impact between the two due to Pluto's dangerously close orbit to Neptune. One of the most peculiar orbits in our solar system is that of Pluto, which takes an astounding 248 years to complete one full revolution around the Sun. This means that since its discovery in 1930, Pluto has not yet completed a single orbit. However, its orbit is not its only unique quality. Additionally, it is far longer than the larger planets' more circular orbits. Furthermore, Pluto has one of the most inclined orbits in the solar system, with its orbit tilted 17 degrees off-plane. This severe tilt, together with its elongated shape, adds complexity. A particularly intriguing feature of Pluto's orbit is how it interacts with Neptune's orbit for about 20 years. Throughout each cycle, Pluto actually approaches the Sun closer than Neptune, contradicting our expectations. What if they ran across each other? Planetary positioning raises the crucial question. Why have Pluto and Neptune not collided? The gravitational forces at work provide the explanation. Astronomers were perplexed by Pluto's orbit in the solar system immediately upon its discovery. Unlike the other planets, which follow very flat, aligned courses, Pluto's orbit is eccentric and inclined. While Pluto's orbit overlaps Neptune's, this does not mean the two planets will collide. A gravitational interaction between them maintains stability. This equilibrium, also known as the three-body problem, describes how Pluto, Neptune, and the Sun interact through their gravitational forces. By predicting future positions based on their current motions and the forces acting on them, this phenomenon demonstrates how Pluto and Neptune are locked in a stable relationship that prevents collisions. Additionally, Pluto's resonance with Neptune, where it completes 2 orbits for every 3 Neptune completes, ensures that the two objects never collide. This unique gravitational mechanism keeps Pluto safely away from Neptune, despite their overlapping orbits. Despite its seemingly chaotic path, Pluto's movement is carefully orchestrated by the gravitational influences of both Neptune and the Sun. This resonance ensures that while Pluto and Neptune's orbits cross, they are never in the same location at the same time. This phenomenon is a prime example of how gravitational interactions shape the structure and stability of our solar system. Astronomers have studied Pluto's motion extensively, confirming that its orbital resonance with Neptune prevents a catastrophic collision. Over millions of years, this resonance has remained stable, ensuring that Pluto follows a predictable pattern. Without this mechanism, gravitational perturbations from Neptune could have altered Pluto's orbit significantly, potentially leading to instability or even ejection from the solar system. While Pluto's current trajectory is secure, long-term changes in planetary orbits can occur due to gravitational interactions with other bodies. However, simulations suggest that Pluto's resonance with Neptune will persist for millions of years, making a direct collision extremely unlikely. Some theorists have speculated about external influences, such as passing stars or unseen celestial bodies, that could disrupt this balance. If a massive object were to pass close enough to our solar system, it could slightly perturb the orbits of distant objects like Pluto. However, such scenarios are purely speculative and not supported by current observations. The broader implications for planetary dynamics. The study of Pluto and its orbital characteristics extends beyond just its relationship with Neptune. It provides valuable insights into how celestial bodies interact over long timescales and how gravitational forces maintain order within a seemingly chaotic system. In addition, Pluto's unique motion has contributed to our understanding of Kuiper Belt objects, KBOs, a vast region of icy bodies beyond Neptune that includes Pluto, Eris, and other dwarf planets. These objects share similar orbital characteristics, reinforcing the idea that the outer solar system is shaped by complex gravitational interactions rather than random motion. While Pluto and Neptune's orbits appear to cross, they are safeguarded from collision by a delicate but powerful gravitational balance. Pluto's 3:2 resonance with Neptune ensures that, despite their orbital overlap, they never occupy the same space simultaneously. This phenomenon highlights the intricate and fascinating dynamics that govern our solar system. Thus, concerns about a Pluto-Neptune collision are unfounded. The stability of their orbits has been confirmed through extensive research and simulations, proving that our cosmic neighborhood is far more orderly than it might initially seem. Instead of worrying about a catastrophic impact, scientists continue to explore how these celestial bodies interact, deepening our understanding of planetary motion and the evolution of the solar system. The future of Pluto's orbit. While Pluto's current orbit is stable due to its resonance with Neptune, scientists continue to study how long-term gravitational influences might affect it. Over millions or even billions of years, small gravitational perturbations from other planets, especially Jupiter, could slowly alter Pluto's path. However, according to current models, its resonance with Neptune remains one of the most stable configurations in the solar system. Some astronomers have speculated that if a massive external force, such as a passing star or a rogue planet, were to enter the solar system, it could disrupt Pluto's trajectory. However, the chances of such an event occurring within the next few billion years are extraordinarily low. Pluto's role in the Kuiper Belt. Beyond its relationship with Neptune, Pluto is one of the most significant members of the Kuiper Belt, a vast region of icy objects extending beyond Neptune's orbit. Many objects in this region share similar resonances with Neptune, indicating that the planet's gravity has played a major role in shaping the belt's structure. The Kuiper Belt is home to several dwarf planets, including Eris, Haumea, and Makemake, all of which follow eccentric and inclined orbits similar to Pluto's. This suggests that the early solar system was a much more chaotic environment, with planets and large objects frequently influencing each other's orbits through gravitational encounters. Could Pluto's orbit change over time? While Pluto's resonance with Neptune is currently stable, long-term simulations suggest that gravitational perturbations over billions of years could eventually shift its orbit. However, this process would be incredibly slow and unlikely to lead to a direct collision. Another possibility is that Pluto could experience a close encounter with another Kuiper Belt object, KBO, which might slightly alter its orbit. If such an event occurred, Pluto's current resonance with Neptune could weaken, but it would take millions of years for any significant changes to become noticeable. The reclassification of Pluto. Pluto's unique orbit was one of the reasons why the International Astronomical Union, IAU, reclassified it as a dwarf planet in 2006. Unlike the 8 planets, Pluto does not dominate its orbit. Instead, it shares its region with many other Kuiper Belt objects. Despite this reclassification, Pluto remains one of the most fascinating celestial bodies in the solar system. NASA's New Horizons mission, which flew past Pluto in 2015, revealed an astonishingly diverse world with towering ice mountains, vast nitrogen plains, and signs of potential underground oceans. These discoveries have renewed interest in Pluto and its role in the broader study of planetary evolution. The idea of a Pluto-Neptune collision may seem dramatic, but it is not a realistic concern. Thanks to its stable resonance with Neptune, Pluto will continue to follow its current orbit for millions, if not billions, of years without the risk of an impact. Instead of being a planetary threat, Pluto serves as a key to understanding the Kuiper Belt, the history of our solar system, and the forces that shape celestial bodies over time. As astronomers continue to study Pluto and its surroundings, they uncover new mysteries that challenge our understanding of planetary dynamics, reinforcing its importance as a crucial part of our cosmic neighborhood. Pluto's unique characteristics make it an essential target for research. Despite being reclassified as a dwarf planet, it remains one of the most intriguing objects in our solar system. Its highly eccentric and inclined orbit, unusual surface features, and potential subsurface ocean all provide valuable clues about the formation and evolution of planetary bodies beyond Neptune. The study of Pluto has also helped astronomers refine their understanding of planetary migration. Many scientists believe that in the early solar system, Neptune may have migrated outward, influencing the orbits of objects like Pluto and shaping the Kuiper belt. Understanding Pluto's history helps us reconstruct how the solar system evolved from a chaotic collection of planetesimals into the structured system we see today. NASA's New Horizons mission, which flew past Pluto in July 2015, provided the first close-up images of the dwarf planet and revolutionized our understanding of this distant world. Some of the most significant discoveries include a vast, icy nitrogen-filled plain that appears to be geologically active. This suggests that Pluto may still have internal heat, challenging previous assumptions that small icy worlds become geologically dead over time. Evidence of fault lines and large cracks in Pluto's surface, indicating past or even ongoing geological activity. Some researchers believe that beneath Pluto's icy crust, there could be a liquid water ocean, kept warm by internal heat and insulating layers of ice. This raises fascinating questions about the possibility of life in the outer solar system. A complex atmosphere, Pluto has a thin but dynamic atmosphere composed mostly of nitrogen, with traces of methane and carbon monoxide. This atmosphere expands and contracts as Pluto moves along its elliptical orbit, making it unique among known celestial bodies. Future missions to Pluto. While New Horizons gave us our first detailed look at Pluto, there is still much to learn. Scientists have proposed future missions that could orbit Pluto, land on its surface, or even explore its interior. Some of the key goals for future exploration include determining the composition of Pluto's interior and confirming whether a subsurface ocean exists, studying Pluto's moons, especially Charon, which may have had a more active geological past than previously thought, exploring the Kuiper belt further, as Pluto is just one of many fascinating objects in this distant region. The bigger picture, Pluto and exoplanets. Pluto is not just important for understanding our own solar system, it also provides insight into exoplanets orbiting distant stars. Many newly discovered exoplanets are small, icy worlds located far from their parent stars, much like Pluto. Studying Pluto's atmosphere, geology, and potential internal ocean helps astronomers predict what these distant exoplanets might be like. In recent years, astronomers have found exoplanets with highly eccentric orbits similar to Pluto's, suggesting that the conditions Pluto experiences might not be unique. Learning more about Pluto can help scientists understand how planetary systems form and evolve throughout the universe. Although Pluto's planetary status remains a subject of debate, its scientific importance is undeniable. From its complex interactions with Neptune to its mysterious surface features, Pluto continues to challenge our understanding of planetary science. Whether as a former planet, a Kuiper belt object, or a representative of distant exoplanetary systems, Pluto remains one of the most intriguing celestial bodies in our solar system. As technology advances, future missions may unlock even more secrets about this icy world, ensuring that Pluto's place in scientific exploration remains secure for generations to come.